I'm sharing my desktop, so what I'm going to do is unshare that, and then please feel free to share your screen, and we'll take it from there, mate.
Okay, can you all see that?
Yes.
Yeah, we can see that, right?
Okay, perfect. So today I'm going to be talking about the lockdown projects I did with the cloud and the MX IoT chip. So we're covering a few different things. We're going to look at the MXChip in general. Then we're going to be looking at the two projects I made, which was an auto-rotating monitor and a LED strip, which you can see above me, controlled using the MXChip and the cloud. So the MXChip is an amazing little microprocessor based on the Arduino, and it's jam full of features. A quick list of them there, but it's got like a screen, GPIO pins, accelerator, gyroscope. It's kind of an all-in-one Arduino dream, really. And the reason I have one is we were going to use them in the second year IoT module, but unfortunately lockdown happened and the assessment for that changed. But I still had an IoT chip and a lot of spare time all of a sudden, so decided to see what I can make with it. So my first plan was to create a screen that rotates like a phone does. So as it says there, you know, when I'm working on documents, like writing assignments, coding to an extent, I like to have a vertical monitor so I can see it all. But, you know, it's a bit of a hassle to go in the settings all the time, change it around, and then you've got to figure, yeah. I wasn't a fan, so I wanted to use the gyroscope on the MXChip to do this for me automatically. So the plan was to have the MXChip talking to a local server. And the reason this wasn't on the cloud was it was right at the start of lockdown, and all the cloud resources were kind of like being used by the NHS and services like that. And obviously I didn't want to take away vital resources. So I set up my laptop as a little MQTT server, which is a protocol that's used a lot in IoT. And the reason I did it on the laptop and not on the computer that was going to be changing it itself is because I had a lot of damp in my room, so I wanted to record humidity and temperature sensor data to kind of prove to my landlord that this was a problem. So once I had that all set up, I need to write the code. And the code is actually quite simple. It's quite intuitive. You just have to enable the accelerometer and get the axes, and then just a few ifs. We can find out which way the chip is facing. And then, not shown here, but I will link to my blog post where I write up all about this. We had to write some more code to send this data to the server. And here you can see a little preview of the final product. And the MXChip is just taped onto the back of the monitor, just with a bit of good old-fashioned sellotape. But it worked fine. And yes, there is a few seconds delay between turning it, but it was still a lot faster than going into the settings. So for my, if I can get it changed, my second project, I wanted to create this LED strip above me. But I wanted to actually, you know, use the cloud for this one. And as you can see, it's working. And if you would like to go to that link, I'll put it in chat as well. You can change the color of the lights behind me as we're speaking. So if you go on that link, it's a bit dirty. It was made in a few minutes, but it should work to change the color of the lights behind me. So the way I got this working was first I had to wire up the LED strips to the MXChip. And thankfully the board is based on the same architecture as a BBC Micro, so there's a lot of accessories already available. So it wasn't too hard to find a breakout board to hook it up. The thing is though, the pins on the breakout board compared to the pins on the MXChip were different. So I had to go through a lot of trial and error, testing every pin to figure out what was the actual mapping between the in-code MXChip and the numbers on the breakout board. But, you know, nice bit of thread. But once I got that sorted out, it was not too bad. So Microsoft have a header for controlling NeoPixels, which is like the brand name for these LED strips. And I'm glad they do, because I had a look at it and half of it's in assembly and it just looked like a nightmare to make myself. So once I had that set up, it was quite easy just then to update the color. So the hard part was getting it getting the sensor data, the color data from the cloud. So here, I've not talked about the cloud yet. It's a bit out of order, so we'll go to that now. So this was the cloud architecture, a lot more complicated this time. So the way this works is we have a IoT hub, which is kind of like the contact point between the MXChip and the cloud. And connected to that is this thing called a device twin, which is like a code representation of the MXChip. So if we update a property in this device twin on the cloud, then the MXChip can pull that and update itself. And if the MXChip updates, then it updates the device twin. So you've always kind of got like this code representation of the MXChip in the cloud. So we can use this, we can update the RGB values in the cloud, and it gets pulled down onto the chip. So we make a HTTP request, a Azure function, which updates this device twin. And this function is what you're playing with now, although I've wrapped it in a nice little UI on the front. So if we go now back to the previous slide, we can see this code here is part of the code for pulling it down and updating the LEDs. So now I had this system set up, I've been interested a while in this thing called a light alarm clock. And the way that works is it comes on at a certain time and the light gradually increases to kind of wake you up naturally, you know, no blaring alarm. That sounded quite nice to me. So my first idea was to leave my computer on with a Python script. But, you know, thinking about it, that wasn't a great solution because, well, I'd have to have my computer on all night and that doesn't sound very nice to me. So no for that. And then it hit me. We're already using the cloud, so why not use like a VM? Well, they have these things called logic apps, which are really nice. They've got like a nice kind of Scratch-like interface where I can easily tell it to turn on at like 6:30 and then make HTTP requests to the lights to turn them on, and then a delay and turn them on, and a delay. For loops didn't work for some reason, so I had to handwrite out all of these delays, but you know, it works. And I can honestly say my mornings have been a little bit nicer. Now I don't have to wake up to a blaring alarm. So that's about it. As I say, this was kind of like a brief overview, and if you visit my website, there's a write-ups on these projects where you can get a bit of a more deeper look at the code. But yeah, has anybody got any questions or just wants to say anything?